So as we begin to talk about this topic and title this The Great Debate, Plans versus Models, there's really a lot to consider when it comes to discussion of this topic. I have material to go on for a while. So as we talk about and think about, and many of us probably are well aware, you're being maybe confronted with, or at least the topic is being batted about: plans or models. What's your deliverable? What do you need to do? What is your objective? What is your goal? What do you need to produce? And we all know, and we can talk about the pros and the cons when it comes to thinking about plans and plan production. I've just highlighted, and this is not an extensive list, but I've just highlighted a few things that came to mind in thinking about plan production. The pros are it's traditional, it's comfortable, it's well understood, there are standards in place that we all know to adhere to. It is a legal document that is maintained and mandated, that is controlled. So our liability is then controlled based off that document, and it tends to be the contractual deliverable that's produced and then we work from. The drawbacks of plans are they are two-dimensional. They do leave some ambiguity in place as far as what's to be done in certain specific areas. There's tedious work and time-consuming work involved to produce construction drawings. There is the potential for errors to be made, moving between sheets, missing notes, missing call-outs, all the types of things that go along with it. But plans are, again, comfortable. They're tried and they're true, and we all know about them. Models, on the other hand, relatively new. We've begun to model things in three-dimensional space more common. It's becoming more commonplace. The pros on models, it's three-dimensional. It really decreases, if not maybe completely removes ambiguity. Some of those details that happen between cross sections in a plan set, or in a high spot or a low spot, or some area on a grading plan become much more prominent, and we're able to see and evaluate those. It increases our spatial awareness. We're able to see how things fit together. We're able to see how the drainage works with the roadway surface. We're able to see how the utilities under the ground interact with the footing of the bridge pier, all those types of things. And then another one I've kind of put on here is the control of the design intent. One of the things, too, that I thought of as I was thinking about this, a lot of times, many of you may have been faced with this in terms of how things work. At least in my experience, contractors a lot of times will recreate three-dimensional model data from plans, which in turn sort of negate some of the design intent potentially in them reconstructing their model from your plans. So being able to provide a model based strictly off of your design intent of what you intended to be built, that's important. The cons of models, the level of detail, we all have probably posed the question, well, what's in a model? When am I finished with the model? Do I include, where do I stop? Do I include the guardrail? Do I include the posts on the guardrail, the bolts on the guardrail? Where do I stop? When is it enough? There are limited standards in place when it comes to modeling. How do I review a model? What's, again, prescribed for me to include in the model in order to meet the requirements for completion of the project or delivery of the model? Legal adoption. Models are, again, not the paper document, so there are legalities in play, or legalities to consider when it comes to accepting a model as a deliverable or constructing a project from the model itself. So that's another consideration. But in terms of the industry of where we are, here's a few statistics that kind of highlight how our industry's project delivery is changing a little bit. And let me clarify as you look at these statistics on the screen. Now, it uses the term BIM, and I'm sort of superimposing the word 3D model when these statistics use the word BIM. And there's another presentation probably where we can discuss BIM and what BIM is and what it means to people around the world. It has varying interpretations depending on where you are in the world and how it's viewed. But in looking at these statistics, where it says BIM, again, I've sort of just broadened that to simply be 3D model. because that's the basis of BIM anyway. And if you note here a couple of, again, looking at the statistics, you'll just kind of note, as we look at the industry, that the use of BIM, or three-dimensional modeling, is the majority of those surveyed. This are engineers and contractors surveyed across European countries and the U.S. There's a majority that are already employing BIM, or three-dimensional modeling. On the statistics on the right-hand side, it's broken down into differentiation between how many contractors and engineers report using BIM on a project, 50% or more of the time, or less than 50%. But I just simply extracted the overall point there is that owners are requesting BIM, or three-dimensional modeling, more commonly now than before. So it is becoming a more mainstream requirement for delivery. You can see that 87% owners, based off of client feedback to this poll, 87% are being required in the U.S., 80% in the U.K., 89% in France, 92% in Germany. So again, in looking at project delivery and the state of our industry and the trends, we are seeing a trend toward three-dimensional modeling as a deliverable, as a process and a methodology and an entity that we need to think about and consider employing across our workflows. Now, looking at those statistics, and again, the state of the industry, and then thinking about ourselves, what our objective is, what the point is that we do every day. I've tried to kind of break it down here. Our objective as engineers and designers is to really employ our expertise to design the project while adhering to standards, while considering the public well-being, navigating the political climate, whatever that may be, protecting the environment, considering public opinion while we do all this, and ultimately minimizing the cost. That is our job, that is our objective as designers, as engineers. But wait, that is only the beginning, and then the real work begins. And that involves, again, delivering the project. Our job is to create and design using engineering conventions and convey that design to the appropriate constituents so that they can review the project, approve the project, and construct the project. So a large portion is, break this down to two main focuses, is design and deliver. And that's kind of where I'm focusing here today. Ultimately, when it comes to delivery of the project, we need to communicate the design. How best to do that? Now, when it comes to delivery, there's a world of types of deliverables. We're focusing on plans and 3D models. But in terms of deliverables, it could simply be anything that the client requires. A deliverable could be considered anything that the client requires that conveys some design intent. It provides clarification of something on the project. It increases understanding of the project and supports construction. That's a deliverable. But in terms of this debate, what is your deliverable? And again, we're focusing on plans and three-dimensional models. Plans, those are our traditional default method for plan project delivery. They are, again, understood, they are well known and comprehensible. Or is it three-dimensional models? Plans or models? What is your deliverable? And that may vary from project to project. Now, really the basis of this entire tech talk is, again, thinking about plans versus models. And I realized a while back that a lot of times our conversations, a lot of times when we have discussions about plans and models, it tends to go one way or the other. It tends to be, we're going to stick with plans and ignore models, or we're going to use models and forgo plans. And as I thought about that, and I began to kind of consider that in reality, and again, looking at this in light and in context of what our objective is, to design and communicate our design most effectively, rather than thinking about plans or models, we really need to think about plans and models. because the constituency that we need to communicate with is broad and varied. So we all are well aware that if you go to a public involvement meeting and you try and display a set of construction drawings, a right-of-way map, whatever it may be, you have to explain that. So we need to produce deliverables, plans and models, so that we can satisfy a broader cross-section to communicate to a broader cross-section of people and interested parties. So in thinking about that, again, in considering who are you talking to, and I'm talking and focusing here on the delivery aspect of our projects. As I mentioned, as we think about who we're talking to and we think about who is involved in the project, in the past, when it comes to plans, they are known. We go through approval processes. We have standards in place for what should be included in the plans, how they should look, what notes should be involved, what sheets should be involved, what order they should be in, and so forth. Well-known, well-documented, standard practice, standard process, and it's in place. Modeling, there's some legalities that need to be developed and be created, but in terms of spatially defining things and clarifying what we mean to a broader set of properties, three-dimensional modeling allows us to do that. So when we think about who we're talking to, again, it's not just plans or models, it's really both to be most effective and efficient at communicating our design of the project to a broader set of people. So three-dimensional models enhance our ability to communicate and convey understanding, and ultimately, again, this leads to the ability to enhance our delivery. And we're all focused on delivery. But again, as we look at the changing environment in which we all do business, in which we all work, in which we all produce our projects, delivery of the project is key. That's our deadline, that's our focus. So being able to do that more rapidly, more quickly, cheaper, faster, better, with less errors, that's important. That's the key. But the other side of this is, like I said, there's two issues. There's the delivery of the project. How do we use plans to deliver the project? How do we use three-dimensional models in delivery of the project? What's the advantages in delivery? What's the advantages of models in delivery? There's also the design side of this. In terms of looking at three-dimensional modeling, there's also benefits just in simply designing and creating and using a three-dimensional model within the design process. So in terms of just thinking about the design, I mean, three-dimensional modeling, whether we could talk about terrain models versus solid modeling, which we'll look at in OpenRoads Designer, it provides, again, a multitude of advantages during the design phase. Simply being able to visualize the design model, being able to collaborate between different disciplines, being able to see our existing utilities compared to our proposed drainage, compared to our roadway surface, compared to the box culvert at the creek at station 200 plus 10, allows us to really arrive at a better design and minimize errors and removes ambiguity much faster in the design process. And that's kind of where OpenRoads Designer comes in. And let me try and I hope can clarify where I'm coming from in thinking about our workflow and our processes. Again, in engineering, we design and we deliver. Well, in OpenRoads Designer, we wanted to kind of increase the efficiency of those two things. And so what I wanted to point out here is that as you're modeling and as you're designing, that the model is being constructed continually. So rather than having a separate process of design, deliver, and having a three-dimensional quote modeling as a separate entity that we have to do to post-process or some extra work we have to do, we want it to all be one, so that as we design, we are actually generating what would be considered the deliverable three-dimensional model and the plans. So that efficiency, rather than being a multi-step process, and this is an interesting topic too, if you think about the things we've done in the past, we went through a lot of work in the past creating terrain models, geometry files, templates, roadway corridors. How many files did we create through the way we've done things, ultimately to generate the deliverable, which was drawings and some terrain model data? So again, OpenRoads Designer is intended to minimize those separation of files, separation of work, so that we blend design, and the deliverable into one type of workflow. So let's take a quick look. When it comes to OpenRoads Designer, if you haven't seen it before, it is a modeling application. It is intended to model and design and model in one comprehensive application. When it comes to plan production, and I'm showing you kind of a cross-section image that you see on the screen here, we provide tools named boundaries to actually provide windows into the design model. So again, rather than it being a secondary process to create some 3D data, then extract a picture of it and put it on a sheet, they are live, they are dynamic, they are intertwined. Okay? In addition to that, again, marrying our workflows as a designer to produce both three-dimensional model data and plans in an integrated, more efficient workflow, we can look at civil cells as an example of technology included in OpenRoads Designer. You'll note here on the screen I've got just a typical detail of a sidewalk ramp, and then adjacent to that I've got the civil cell display. So what this represents again is a pre-built, predefined, parametric, constrained ramp constructed in 3 dimensions that follows the criteria specified on the detail sheet. So again, what you see in this example of a civil cell is again the marrying of the data, the parameters, the specifications for that ramp into a 3-dimensional modeling element that we can store in a library and recall and use over and over and over again in a design. Okay, I hope that makes sense. But again, it highlights again the convergence of the plan specifications, which we've detailed out on the screen in the typical sheet we'd have, and the modeling element, which we'd use in our design model. All right, so let's take a look at OpenRoads Designer. So again, in context, thinking about designing and delivery. So as we start here, I've got multiple views opened in OpenRoads Designer, and we're focusing first of all on just the modeling aspect. As I said before, when it comes to designing, being able to model quickly and efficiently is extremely beneficial, just simply to see what's going on. So what we're doing here, I'm just going to place a fire hydrant. I have an existing water line along the south side of the roadway, and then I'm going to just open up and I'm going to place a fire hydrant and tie into that existing water line. Okay, so I'm going to go place a lateral. I'm going to select the feature definition that I want to use, which again is a fire hydrant. And within terms of the feature definition, that basically defines what I'm modeling. And now I'm just going to tie that fire hydrant into an existing water line, which you see has just been referenced into my design model. You see it in the plan view on the left, and then you can see it in the 3-dimensional model view on the right. So as I begin to place that fire hydrant, I'm actually going to place it in the 2D top view. Now I'm using, again, sort of traditional methodology here in placing that element in the 2D view, but notice it's being constructed in the 3D view. And again, this really shows that convergence that we wanted to incorporate in OpenRoads Designer of work traditionally, produce 3D. So that 3-dimensional model, again, is just, it's there, it's inherent, it is part of what we're doing. So again, we've just tied in, we placed a proposed a fire hydrant onto our roadway model off of that existing water line. And we now see that in the model. There are cross-section views we can move through. What you see on the screen, you see the plan view, again, in the top left, and profile view in the bottom left, and we see the cross-section view in the lower right. Now, let's go over in the top view. I'm going to just turn off the imagery. I was streaming imagery in from Bing Maps. That is a new addition for OpenRoads Designer Update 2. If you're not aware of it, you can stream imagery in directly into your file if it has a coordinate system. So that's a cool addition that makes things a lot easier rather than searching for raster images and making sure they all line up properly. So again, there's the plan view. Now let's lay out a little bit of a drainage network. So I can, again, just as I did with the fire hydrant, I can go along the model and I'm just going to place some inlets. So I'll select the roadway corridor. Select the element, which is the roadway corridor that I want to use. Now, again, this is being integrated, so I'm placing a drainage network relative to my roadway. The elevation's being selected based off of the roadway corridor surface, which I selected. Now, you can see that drainage network, and you're able to see the grate. And I'm doing this sort of haphazardly here a little bit, just placing it in there kind of quickly. Now, I can change the view if I want to get a better perspective of the model itself. So we see the buildup of the roadway, the curb and gutter elements, and the drainage structure as well. So I can go through, place a couple more structures, rotate that structure, and we'll just pull that over. See the view now of that structure that was just created. We can modify that structure if we want to use a different type of structure. The feature definitions are completely customizable. The structures themselves are customizable. So based off the feature definition, you can place a three-dimensional structure defined however you want, whether it's rectangular structure, circular structure, different type of grate configurations, whatever that happens to be. All that's customizable, and you can construct whatever standard you need. Now, again, if looking at this model, at this point, I'm thinking as a designer. At this point, as a designer, I see the intersection. I see existing utilities. There's a fiber optic line on the left-hand side of the roadway. There's a water line on the right-hand side. I can move through that and interpret that model in cross-section view. So I've got the ability to dynamically jump through those sections, again, as a designer to evaluate and see what my design is, how things are working. Now we can just connect those structures up. We see those structures present in the dynamic section, and I can just take a look at that. Now we're going to place a pipe and just connect those structures. So we'll pick our pipe that we want to use. We're going to use a concrete pipe. Select the diameter that we want to use for this particular pipe, and then just select it within the model to connect the pipe, connect the inlets with the pipe. So again, what we're focusing on here is just really the interactivity and the benefits of a three-dimensional model in terms of design. So we can see that pipe being laid out, again, drainage network relative to the roadway, relative to existing utilities, all again in one sort of comprehensive environment. Now, we're going to jump ahead just a little bit for time's sake and focus a little bit more on deliverables. Now, there are tools within OpenRoads Designer for annotation, for calling out stations and offsets, whether that annotation exists in plan, whether it exists in a profile view, whether it exists in a cross-section view. So here, I'm just kind of continuing on, placing a station and offset along that existing utility, and that text, that call out, is dynamic. If the roadway center line changed, it would update. It would all be dynamic. Now, what I want to do, let's jump forward just a little bit. So we've placed annotation into our model. Now let's look at producing a cross-section within the model. And so now, based off the design model in which we constructed our drainage, modeled our intersection, set the grade on our roadway, included a retaining wall, now we're going to move to producing a plan set. And I'm just going to create cross-sections. I'm just going to kind of do some custom cross-sections. These might be considered drainage sections or something. So I'm going to just place them across that roadway corridor using 2 points. So I'll select the drawing seed, which really controls my border, my standard behind the scenes as to how I'm going to build these sheets. type in a name for the group that I'm creating. And at this point, I'm creating named boundaries. I'm creating the windows into the roadway model that will be the views or the windows, the slice of the model in my cross-section sheets. So I'm just going to quickly place a few of these throughout the model. And again, I'm sort of just haphazardly placing these. These would be considered custom cross-sections. So I've placed one at the first drainage structure. I'm going to go in and just place another along the intersection. Just select the alignment, and then I'll select the left and the right point, the extents of the cross-section that I want to create. And you can see those views, those windows over in the 3D model. Now I'll pick another area. Let's cut a cross-section and we'll skew it a little bit through the drainage structure, and then data point to accept it. Now there are our named boundaries into the model. So now we are looking at the planned delivery of our project based off the design model. And so now we have the cross sections. You can see those displayed in the model. I can turn them on, I can turn them off. Again, these represent named boundaries, or I just call them simply windows into the model, and they will be placed onto a cross section sheet when we produce the drawings. So I'll open up again that set, and I'll just create the cross section drawings themselves. So now, again, I've only got a few. I'll end up with one sheet, but based off of those named boundaries, based off the model data in which it's existing, which it's cutting through, that produces my drawings. So we see the drawing, the cross-section sheets now on the screen. You see the drainage structures in place. See the pavement layers. So there's the one drainage structure. We can look at the properties of it. Again, this represents a three-dimensional entity in the model. And we're looking at a view of it in our cross-sections. So we've got the three sets, or the three sections created now. There's our intersection as defined. And then finally we have the last cross-section. And now the interconnectivity of plans and models. I can jump from this particular drawing into the drawing model or into the design model. So from the drawing, I can jump into the design model. So here we see that sheet based off of, again, the representation it sliced through in the design model. And I can just turn off the clip volume, and we can see the relationship of that sheet to the design model itself. Now again, I think it's extremely cool to be able to jump from the drawing to the model, or from the model to the drawing for that matter. Again, ultimately increasing efficiency, whether we're delivering plans or whether we're delivering models. And so there you see the cross-section in relationship to the design model itself. Again, just sort of put together in the model view so that we can see it nice and neatly. We can change the view if we want to, if we need to modify and change things around. Change the display parameters to transparent if we want to see things in a different way. Now, in addition to coupling, I guess you'd say, plan production and modeling, designing, modeling, and plan production. If we look specifically at the cross-section at the intersection, so we see the cross-section. I've opened that sheet up independently in a separate view. And now if we go and modify the profile of that intersection, what's going to happen to the cross-section representing that design model? So I've opened up the profile, so I'm looking at the design profile. I have the 3D view opened in the top left, the actual sheet view opened in the top right. So if we modify now the profile of the cross-section of the intersection as it relates to where we are currently. So let's pick it up, let's change the profile, and now watch what happens in the model and in the plan sheet. So watch the cross-section, watch the model. So now those updates, since it's based strictly off the model, are applied throughout. And again, that cross-section, if we make another quick modification, notice it updates based off of what we do in the design model. So again, model and design and impact deliverables at the same time. Again, ultimately trying to increase efficiency, streamline the process, and move at a more rapid pace. So we've got just a little bit more time. I'll highlight here just a couple of a tech preview. What I wanted to do in thinking about OpenRoads Designer and again coupling modeling and delivering our projects, what you're seeing on the screen, it is a tech preview. It is available in Update 2, although not fully enhanced as it will be in our next release. But what you're seeing is basically the ability to open a profile view, select a window, and then display the three-dimensional model data based off the model into that profile view. So we're able to, again, take the profile view, clip out, place a window, and say, I want to see the three-dimensional model data along that profile in my profile window. So again, it's really given us a way to integrate or a couple or marry plan production and modeling into one cohesive workflow. So now, if we take that step farther, and we want to apply this to sheets, we have the same alignment, same roadway corridor. We have a boundary created in the profile view, and this would be a boundary we've created for a plan and profile sheet, for example. And now I'm going to use the same tool. I'm going to define my window based off of that named boundary, data point, and again we see the three-dimensional elements in the profile based off of the selection. I can modify the extents of that if I want to shorten it or widen it so that I see model data along a different station range or something like that. And then we can move up and move to the named boundary tool and actually look at the results in the sheets. So now we've got the boundary created, and we're just going to create a drawing from it. So you see that the interpretation of the inclusion of that 3D model data in the dynamic profile and in the boundary that we're using on our sheet is carried forward into the plan production. So again, ultimately it is simply to marry the workflows between design and delivery in order to make the debate between plans and models much more seamless. So, what's the point? What is the point? We started out talking about the great debate, plans versus models. And as we've talked about it and discussed it, and as I thought about it, and as I went through looking at practically speaking, is it plans or models? It really becomes, I think, plans and models. If our objective is to deliver projects more effectively, more efficiently, then really we ultimately are going to need to deliver plans and models. And every project will be different. There will be different requirements on each and every project. There will be different standards that we need to adhere to. There will be different needs. So we should begin to think about, rather than plans versus models, think about plans and models. And we need to be really thinking about that in light of some of the delivery methods that are becoming more commonplace. Think about design build delivery methods, or CMGC, where collaboration is key, and we need to share data quickly and efficiently in both plans and three-dimensional space. Being able to produce plans and models and share that data more collaboratively is key, is extremely important. And also, too, finally, when we think about plans versus models, or we think about plans and models, it really comes down to two discussions. It comes down to a discussion of plans versus models for delivery. And we think about, okay, plans are great when it comes to delivery because I know what I'm looking at. I know how it's supposed to look. I'm going to look for these specific notes, these specific callouts. I need these sheets. I need these, this, and then this. Plus, it's where I can manage my legalities. We need to think about providing models in a delivery state. Well, it's great. It's 3D. I can visualize from it. I can reduce conflicts. I can show the contractor what I'm wanting to do. But How do I manage legalities? How do I do this? And we need to think about plans and models in terms of the design phase as well. What's the benefit of plans in the design phase? What's the benefit of models in the design phase? And how do we apply plans in the design phase? How do we apply plans in the delivery phase? How do we define or utilize models in the design phase? And how do we define or utilize models in the delivery phase? So, as I said, as we got started, it's really quite a broad topic, and it really sometimes in conversation, as we talk about it and as we debate it, sometimes the discussion goes, well, we could have a long discussion about pros and cons, what are the advantages, what does the future look like, how can I take advantage of it? Well, I hope it was beneficial to you. Again, I think the bottom line, the key when it comes to debating plans versus models, is for us to, again, go back to our main objective, the heart of the matter. As engineers and designers, we need to provide most efficient and effective means to convey our design intent. And that's not just plans and it's not just models, it's really both. We need to be able to design, model, and produce deliverables in a much more efficient way than we've done in the past. And ultimately, that is the objective of OpenRoads Designer. So, all right, well, that is my summation. So thank you for your time. I think we are open to discussion or questions.